Do you know that most companies still have an AD environment? Now, with this being the case, they're susceptible to a few different attacks. But the one that we'll be talking about today is one that doesn't even need your password to work, and that is AS-REQ roasting. It's Novice here, and I'm back with another video. Today we'll be going over how to actually build out that AS-REQ roasting tool. Now, for those that don't remember, a big part of this tool is building it out using AS-REQ. And if you don't know what that is, feel free to check out my last video. I'll put the link in the description. But moving forward, this tool was created using Python, and it drew a lot of inspiration from impacket. It's more specifically that get NP user tool. But without wasting any time, let's hop right into the code. Okay, I pulled up the code. Now, and this one is going to be a little different than most of the other ones where I've been building out tools, where I'll build them right in front of you. And that's specifically because it took a long time tooling to make this one really work. So I'll probably just review it now. We'll go over it. We'll do a test for it, and then finally we'll grab that hash. Now, I was also thinking about showing you how to crack the hash, but we have an entire video on password cracking, so I'll just grab the hash and then that will be it for this video. Now we'll go ahead and start with the code. Now, as you can see, there are 4 different files and each of them have some sort of significance. Now, we're gonna start in the AS-REQ roasting one because that's where the main code lies, and then I'll describe the rest of them as we go on. So in this code here, we start off by making the variables as global variables. That way they can be used in any of the functions that we have available below it. So we'll go over some of the flags. So we have DC. So for this to work, we need to grab the DC information so that we know what we're connecting to. DC holds the KDC, and this is what a client will need to communicate with to grab the AS-REQ message. Then we have users. So for this, you're gonna have to provide a name for a user. Now, as we know with AS-REQ roasting, it works if you have the name of a user who has pre-authentication disabled. So you do have to have their username, and here we have 2 different options to do so. Either just entering their username or putting their username within a file, or putting multiple usernames within a file. And then at the bottom here we have domain, because the domain name is needed as it is actually going to be set as the realm, which is a field that we went over in the last video, but it's going to be set as the realm for most of these, for most of the messages here. Then moving forward, we have an output file. So this is kind of the same as when we were building out the password cracker. Having an output file just in case you don't want it all cluttered on the terminal. You have the output file, and that can hold that information for you. Now we can move forward. Now, instead of starting here, I'll actually break this this function down a little later because it is in our code. We'll actually start in the grab AS-REQ function because this is where everything, the magic really happens. So in grabbing AS-REQ, the first thing we do is we set a variable equal to AS-REQ. Now, I'm gonna go through the AS-REQ file because this is going to show you what this is and why it's needed. So if we move this here, come in here, there are going to be a lot of different classes here. We'll probably go over each of them as they come up in the code, but for now, this is what we need. So what we're looking for is AS-REQ, which should be closer to the bottom, or AS-REQ. So here it is. Now, in the prior video, we talked about tags and why they're important. Now here we can see that this is the tag class, which is actually the class of application, and then the tag type, which is tag format, which is actually constructed, as I spoke about before, because these are actually going to come in as sequences. And then finally, the number that actually identifies what this message is 10. Now 10 stands for an AS-REQ message that's being sent to the KDC. Now, as you can see, a parameter that is passed in here is actually the KDC request. And because of that, we're gonna go through and look at what the KDC request actually does, because it plays a vital part in why the AS request actually works. So in the KDC request, we talked about this in the prior video as well, but essentially what we're doing is that we are setting these fields and their values so that they can either hold information or we're setting them with information. So the pvno component, like I said, I'm gonna break this down as we go through each of these, so I'll actually go up to where this function lies. Now, what VNO component is actually doing is that it's grabbing the tag value. Now this tag value actually acts as the order, or a way to order the different fields, because when dealing with ASN1, you do have to have your fields in order, and to do so, we have the tag value here that makes us able to. But essentially, we grab that and then we place it into this sequence component. So coming down to what sequence component does. Now sequence component essentially grabs the name. In this case, it's going to be pvno. As we can see right here, it grabs the subtype, which is a compilation essentially of all the information within it. We state that it's an explicit tag. Now this is very important because I messed up on this code quite a bit because I did not set it as an explicit tag, but an explicit tag is needed. But using the explicit tag can then set the class, which, as I said, for most things within sequences in Kerberos, we're going to use that class context specific. Now in Python, there's something called AS-REQ, which essentially grabs all of that information and it has it in its own, stored in its own way. And tag class context actually stands for that context specific class that I spoke to you guys about prior. And then here we have the tag as tag format simple. Now tag format simple is essentially just the format of primitive. Here is just represented as simple, but that's what it stands for. And then here you actually place in the order, which is the tag value. Now, as I showed you in the last video, I might even pop it here now so that you guys can see it. Within the KDC request body, no, within the KDC request, let me start there. pvno should start with the value of 1. That should be understood right there. Now, next we're gonna move on to the message type, which is the second value within the field for the AS-REQ request body. Now, when we look at this, essentially I placed in 2 different values. So 2 is the order of it, so it goes 1, 2, pdata 3, request body 4. Now 12 or 10 and 12 actually act as constraints, I believe. Yeah, constraints in this message type component. But instead of guessing, we can actually just go up to the message type component to see what's happening over there. So in message type component, we are getting the tag as well as the values, and then we're setting the values as constraints. Now, as I said prior, constraints actually just act as a way to tell you that only certain values are allowed and other values are not. Now, here it then pushes it to sequence component, which we just saw, but I'll scroll up so you guys can see it again. And then it states the name as message type, and then here it places the tag value as 2, and then gives it the class of context as well as the format of simple. Now when I go down, we're also going to see this sequence optional component for PA data, so I'll go ahead and explain it right now. So the only difference between sequence component and sequence optional component is that sequence component is mandatory for the message to have. Optional, this does not have to be the case. If it does have the information, that's great, but it's not necessarily mandatory. And because of that, if it's optional, you could have something blanked out for that specific field. Or you might not have to specify the field at all. But coming back down here, boom. So sequence optional component. PA data is actually going to store that component as its own separate sequence, and then store that in this KDC request as well. And then finally we have the request body. Now, as I spoke to you guys before prior, the request body is going to need another sequence within it, and that is what is fulfilled by this KDC request. And actually the PA data also has to have another sequence within it, which is that PA data. So I'm gonna actually review both of them now and tell you why they're important. Just gotta find them. I'm gonna go over PA request or PA body, PA data first, and then go over KDC request body after that. Let's just try to find PA data. Okay, here it is. So in PA data, as I reviewed prior, it essentially creates the PA data type within the sequence and then creates the PA data value. Now, like I said, these numbers after the fact are their tag values, which list the order in which they should come in. But these at the very end actually list out the type that is needed. As I told you prior, with primitive types, you'll have types such as integers, booleans, etc. And then with constructed type or format, you'll have another sequence that you're using. So in this case, the type would be an integer, and in this case, it would be an octet string. Now next, we're gonna go down to Kerberos request body, which is right here. Now as you can see, we list out we list out all 11 actually. So we have the KDC option, CNAME, realm, SNAME, from, till, RTime, nonce, eType, address, encryption data, encryption authorized data, as well as additional tickets. Now, I do want to specify here that not all of these are needed to get the AS-REQ message from a user who has pre-authentication disabled. So in the code, you'll see that some of these are actually not being used at all. And that's not necessarily a problem. It just means that it's not necessary to grab that AS-REQ message that actually shows what their hash is, and then after that we have to crack the hash. But essentially, I'll go over the things that will be needed in this request body, because when we go back to the AS-REQ roasting.py file, those will come into play as you'll see them and where we're actually substituting the values in that should go within these actual fields. So we will need KDC options. Now KDC options, the best way to explain it is that it gives the options for the KDC to do whatever it needs to do. And you'll see that more once we actually get into the code, because I don't think I'm explaining it that well. Now CNAME is just the client name. In this case, is going to be the name of the user that we're trying to grab the AS-REQ message for. The realm, as I said before, is going to be needed for the domain. The realm is going to be needed for the domain. Then we have the SNAME, which is the service name. Now, in the case of Kerberos, the SNAME, especially for an AS-REQ roasting attack, is always going to be KERBTGT / the name of your domain. So whatever is inserted in this realm, essentially. And we're gonna need a few from here. Let me see which ones they are though. We will need RTime and till. I wasn't sure if we needed the from. So we need till and RTime, which are essentially just telling them the times at which we're trying to access the KDC. Then we have a nonce. Now the nonce is genuinely just a random 32-bit value. And then the eType, which tells about the encryption types that the KDC should and can encrypt the AS-REQ message into. So let me repeat it again so you know which ones we're actually going to be focused on. That is KDC options, CNAME, realm, SNAME, till, RTime, nonce, and eType. Now I'm going to switch this back over because that essentially covers everything that is meant, or everything that is important within this AS-REQ message as it pertains to us getting an AS-REQ message. So because of that, we actually come to CNAME and SNAME. Now with CNAME and SNAME, they're actually also using a different class, and that class is known as principal. So I'll come in here, show you guys what that class looks like. I think it should be closer to the bottom, I might be wrong. Yep. So here, essentially you have the ability to set a value, set a realm, and set a type. So the realm is most definitely most important for the SNAME, because the realm usually comes with it. It will be curved TGT / the realm. So it will be quite important there. But essentially what this entire class is doing is that it is going through any value that you actually input as that first value and determining what is meant by the username or the actual service ticket or curved TGT account. Now once it does that, you essentially get back the username. So in this case, we're gonna test it with alice.j. When we place the username into the principal, we'll get back that alice.j. And then same thing with principal, as we put in the curved TGT / the domain.upper, because we want the domain to be upper. It will return the same thing. Now moving forward, before going into the request body, we do have to still do the things in the AS-REQ request sequence, which involves setting the PVNO, the message type, as well as the PA data, and then the REQ body, which we'll do at the bottom. So the PVNO essentially looks like it's telling us what version of Kerberos we're using. So for that, we're going to use Kerberos 5. Now the message type, it tells you what type of message that you're doing, and that is 10 for the AS-REQ message. Now this is where things get interesting, because this is where we play around with PA data. So we have to create a PAC request, which is a privileged access account request or privileged access control request, which pulls out the information on what the user can or can't do, and then we do include that here. We don't actually use that information in AS-REQ AS-REQ roasting, but I thought it might be helpful for future contexts, but save that for later. Essentially, I encode that and then I place it into that P data value. And in P data type, this is just 128 stands for a PAC request, the same way that 10 stands for an AS-REQ message. Now moving down, we get the REQ body. So within our AS-REQ sequence, we have the request body. Now I already went over what we need in that request body, so I'll go through here and then show you what is needed and then how to set them. So first we need the kdc.options. Now for that, we created a list and then appended the numbers 1, 3, and 8. Now this means that the KDC is forwardable, proxyable, or renewable. And then we set those options there. Then at some point we have to encode those options using that encode flags function up here. Essentially what that does is that it creates a 32-bit value with all zeros, except in the places that we have stated should be 1. So in this case, we said that value or index 1, index 3, and index 8 should actually be the value of 1 instead of 0. So come back down here. Boom. And then with that, we're done setting the KDC options. Like I said, realm, I went ahead and set that one first before CNAME or SNAME, because it's just going to be the domain in an uppercase value. Then coming here, we have sequence set and sequence set. Essentially, this goes through to set the SNAME in request body as the SNAME that we had in our prior principal. So that means the service name is now going to be equal to curved TDT / whatever your domain is, and then the CNAME is going to be equal to something like alice.j. Now coming down here, we kind of start to preset the encryption types. Now, the one that we most likely will get is actually this 23, which is the one we want to get. But these two values might also be necessary in case your KDC says that it does not support just RC4 HMAC. And then you can see the values and what they represent through the comments beside them. And then we place them in the supported ciphers. And then down here, we actually set the E-type as those supported ciphers. What this sequence set iter does is that it sets that value, but it does it for every value within this. I guess this might be considered a list. Now from there, we actually have to get the time so that we can set our time until. So we get whatever time it is now in UTC, and then we add it by 1. And then we place that within our time until, and then that's essentially all that we're doing. I could go over this to ASN1, but essentially just converting it to a format that ASN1 accepts. And then from there, as I said prior, the nonce is just a random 32-bit value. So what it does is that it gets a random 32-bit value and then puts it in the nonce. And then we just explained what happens here. And then from there, we have to encode the entire AS-REQ message. So what we've been doing this entire time has been setting up values that go within that AS-REQ message. So AS-REQ, PVNO, message type, PA data, and then here we set request body as AS-REQ request body. So as we're setting that request body, it's still going back into this AS-REQ. So from there, we actually start to encode that message. Now, after encoding that message, all that's left to do is to actually send that message over to the KDC so that it can accept it, or to send, it can accept it and send you an AS-REQ message, or it can decline it and send you a Kerberos error message. So essentially this connect here is trying to connect to the KDC and then transfer that message to the KDC that you specify here. So I'll actually come in here, give you a brief rundown of what that looks like. So within connection.py, we start off with this function, but we'll actually come back to that, as that is a function that's used inside the create connections function. So within the create connection function, we have a few parameters, arguments, which are data, address, and then port. So as you saw in AS-REQ roasting, we have our message, which is our data. We have our IP address in this case, or the host name in this case, which will be our address. And then we have the port defaulted to 88 because that is the port that usually accepts Kerberos messages. Now, from here, we grab some of the address information from this line. Then using S, we create a socket, and then using s.connect, we connect to this SA right here. Now, essentially, this is building the connection between the client machine and the KDC so that we can then send those Kerberos messages across smoothly and soundly. So essentially, that's the first part of what this does. So after it connects, obviously it's in the try and accept block so that if anything goes wrong, it gives us the error. But then it sends all of the message, first starting with the message length and then followed by the data. Then down here, we have response length data and then receive exact, which is this function up here. So essentially what this function does is that it grabs the socket as well as the, I believe N would be, let me come back down here, the amount of bytes is expecting to receive. So essentially this is just receiving the length of the KDC reply to what the client has requested. In this case, the AS-REQ or the authentication server request. From there, it stores that length into this length value, and tells us what the exact length of the response is going to be. And then from here, we just make sure that we get all of that length by using this while loop, which essentially adds this more function to this data function, which right now is empty, until the length of data is greater than n, which makes sense. Well, greater than or equal to n. So once that is the case, it exits and then it returns data. So in this case, it's going to return the response length. Then we come down here and unpack the response length. So essentially returning it from bytes into its actual number format. And then from there, we actually put our entire message back into it, into the receive exact, and then the response length. Now that we've unpacked the response length, once we receive the response length and then unpacked it so that we have the actual value, we then push it back through to the function that then retrieves our response data. And then from here, this is where it gets a little interesting and where it goes into the Kerberos error that I pointed out in our prior video. So essentially the Kerberos error is a different schema, a different message than the AS-REQ. However, it's very much necessary in case something goes wrong so that you can see the problems that you're running into. Essentially, it helps you so that you don't continuously bang your head into the wall without knowing the issue. This helps to point out what's going wrong so that you know exactly where to focus. So now we're going to go back to the AS-REQ.py so that we can show you that Kerberos error schema. We essentially went over it prior, but here you'll get to see how it looks in Python form. So let's try to find it. I'm looking for KRB_ERR. Here it is. So here we go through the tagging situation again. So we tag it as a class application, and then from there we tag the format as constructed because this is going to be another sequence, and then we input the number 30, which represents a Kerberos error. And then from here, it should look pretty similar to what we had within our other video, but I'll probably pop it on the screen here as well so that we can do comparisons. And essentially we're getting PNBO, we're putting it as a value of 0, and if I'm not wrong, the type should continuously be int32 based on this function that I showed earlier. But let's check real quick. Yep, integer. Well, not int32, but integer. Now we come to the message type component, which has a value of 1. Like I said, these values here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they essentially spell out the order that these components / fields should be in, because these fields have to be in this certain order for the KDC to know that this is the actual message that you're trying to send. Now, from there, we have some optional components, ctime, cusec. Now, these are not things that we're constructing, these are things that we're receiving back. And so we don't really need to define any of these values because these should be what are returned from the KDC. But if we need to pull them out, we can we can grab those values by grabbing the schema and then specifying which of the fields we want to pull. And in our case, if anything goes wrong, error code here is usually where we want to look at. So moving back to the connection. So essentially it just tries it to see if we're getting an error. If we're getting an error, or if we don't get an error, it still returns that response data anyway. But essentially we're trying to see if we get an error first so that we know if we do have an error. If we don't have an error, it just sends that message back to us. And then as we scroll down, so we kind of do what we did in the KDC. So now connect essentially has all of that information from what should either be the AS-REQ reply, or I said AS-REQ reply, the AS-REQ message, or the Kerberos error, which are two different type of Kerberos messages we can receive. Now, essentially what we have to do is decode it as the specific schema that it is. So if it returns and it's in the schema of Kerberos error, it's going to try to do it in Kerberos error. If it doesn't return as such, it's going to assume that it's an AS-REQ reply and return it as an AS-REQ reply. Now, if anything else goes wrong, it essentially just raises an exception that lets us know that this user does have pre-authentication enabled, or there has been an error. And in that case, it'll be on us to actually go and see what's wrong, or trust that it probably has pre-authentication enabled. Now, after receiving that from Connect, we have now just decoded it so that it's in a readable format for us, because prior it's bytes. And now that we've decoded it as either Kerberos error or AS-REQ message, we can now come to this bottom part. Now, essentially, if it is an AS-REQ message, this is the only possible way that this bottom part can work, because essentially it checks if AS-REQ has an encrypted part and an E-type. Now, if I go back to AS-REQ.py and take you to AS-REQ, here essentially we get the tag set. We go through and do what we've been doing similarly for AS-REQ and Kerb error. We grab tag.tag class application for the class, tag.tag format constructed for the format, and then 11, because 11 represents a message that is an AS-REQ message. And then from there we have to go see what's in the KDC reply, which is right here. So within the KDC reply, as you can see, we have the PVNO, and this time it starts with the value of 0, the message type, which is an order of 0, then an order of 1. PA data has an order of 2, CROM order of 3, CNAME order of 4, ticket order of 5, and encrypted part order of 6. Now this is what's most critical, because this encrypted part here is where we actually get the information for the E-type. Now, as I said previously, the E-type is the encryption type that is used, and that is very important to know, especially when you're trying to crack a password. Because if you're using the wrong encryption type, if you're trying to crack an encryption type with the wrong encryption type, it's not gonna work. So let's use an example from the password cracker. We had SHA-1 and MD5. If we have a SHA-1 hash and we try to crack it with the MD5 hash, we are not going to get the right answer. So with this, essentially, we go through and have it set up so that if the E-type is 17 or 18, which are AES-256 or AES-128, we'll actually set up the hash so it's exported in a way that Hashcat can essentially grab it and then decode it if it is found within a dictionary file. So essentially, it goes through, it gives it this little beginning, which is Kerb5 AS-REQ, and then it grabs that E-type. So if it's 17, it puts 17 here. If it's 18, it puts 18 here. Then it uses $username, $domain, $. Here it's essentially grabbing a part of the cipher, which is also in the encrypted part, or encryption part. Encryption part. It grabs that and then it kind of splits it apart. So it grabs the last. Wait, let me see how to say this. So this goes from 0 to -12. Oh, okay. So it grabs from 0 to -12. So that's 12 away from the very last digit. It grabs those. And then these grab the last 12 values, and then they separate them, and then use a hex 5 I don't know how to say that properly, if you can tell. It grabs that, puts it together into something that Hashcat can actually break down. Now something similar happens down here, which is our else statement. Now most of the time we expect it to hit the else statement because most of the time, especially with data that's pre-authenticated, we can expect it to kind of come back in this RC4 HMAC. It's still possible to get the 18 and 17, but for me, I've seen it mostly as that RC4 and HMAC. Not sure if that's just the environments I've been a part of, but most of the time I'm looking to come to this else section here. So essentially, it does something very similar here, but in the username and domain, it changes the $sign that starts off the domain into an @ symbol. And not only that, it uses the first 16 characters as the first part of the encryption, and then the last 16 characters as the next part. So those would be the only two differences to look for. Although the decoding part would be difficult to see, especially for the cipher part, I would say to try more so to look at the E type, which relates to the number, which then relates to a specific encryption type. So say for instance we have 17, we then know that we're using, I believe it's AES-128, am I right? Yes, AES-128. If it's 18, we know it's AES-256. And in our case, if it's 23, we know it's using RC4 HMAC. So that's essentially what this code is supposed to do. And then finally, we kind of put it all together in our main file. And in our main file is essentially where we get to use most of our flags, because the grab AS-REQ is essentially doing most of the work. And then the main function essentially is using our flags so that we can properly export or import information in the way that we want to. So that if we want to use a user file or just a single username, we can. If we want to use an output file or not use an output file, we can. If we want to use the DC's IP address instead of the host name or vice versa, we can do that. That's essentially the main function of name. All right. So essentially, this checks to see if there is a user file. If there is, it reads that user file and then stores the names into users, stripping any white space, and then separating them based on new lines that they're on. Now, if it's not RX user file, it's just going to be a single user. So you get that user and you put it in the CIDIS users list. Now, results is what's going to hold the results that come out of this experiment, essentially. And then finally, we have for each user, we go through, we do the grab AS-REQ, which we did at the top. It pretty much verifies for each user if they have pre-authentication enabled or disabled. If it's disabled, it essentially goes through what I just showed you and then prints out those hashes at the very end. Now, if it's not, essentially it just prints out no AS-REQ for that specific user, and that should be it. And then if something were to go wrong, you would get this. Now, we can play around with it and see. I think what actually happens is that this is printed when there's no AS-REQ or if pre-authentication is enabled, but we'll test that instead. And then finally, we actually come down here for if it's asking to do this in an output file. So essentially, if it is, it then writes the results to a specific output file that the user specifies. If not, it just prints the results to the terminal. And then finally, we call the main function. So that's essentially what this script is meant to do. This is our AS-REQ roasting tool. What I'll probably do right now is go over this more in depth, or I guess go through each section and why they're important for this. So as I said, this sets the PV&O value, which we see in each of the 3 important message types I described before: AS-REQ, AS-REP, and Kerberos error. Same thing with the message type here. Oh, this is not message type here. Now the sequence component essentially just builds out the fields for any of the fields that are within any of the major sequences. So that being AS-REQ, AS-REP, Kerberow's error, and any other sequences within this file. I have to say that because with these sequences, if there's a sequence within a sequence, we're most likely still going to use either sequence component or sequence optional, because that means there's more fields within the sequence that is within the sequence. Alright, you're going to run message type here. So Kerberow's exception. Then we have int 32. Essentially, it sets this wide range of integers as the constraints. So anything larger than this or smaller than this will not work. This essentially just uses any integer since it passes this in. Now with Kerberow's string, it just has the encoding of UTF-8 and uses this general string, so nothing too crazy there. Realm passes in Kerberow's string, so there you go. Now with microseconds, it sets a constraint from 0 to, I believe that's 999, how do I say this? 999,000, I don't know. You see 6 nines there. And then principal name we already went over. It's essentially what's used to grab the username and the service name in this case, which is curb tgt / your domain. PA data we went over as well. It's built to build out the sequence within the PA data. Yeah, built to build out the sequence within PA data, because the PA data within the, I believe it's the KDC request, is also a sequence with fields within it. So this just lists out those fields so that we can just use it smoothly. Then we have Kerberow's time, which just uses generalized time. Kerberow's error, explain that one. But with this, you can kind of see where some of the fields come into play. Now these essentially are just telling you what type of value they're expecting. So this one's expecting some sort of time value. This one's expecting something from the microsecond, so something within that 0 and those 6 9 ranges. Another time, another range, an integer, and then realm. Did I skip realm? Oh, realm is expecting some sort of string, and that's kind of why our domain works. Then we have principal name, realm, principal name, Kerberow string, octet string. So essentially what this is doing is just validating if you want to include this include pack here. So if you say true or false, like if you say true, that means you want to include it, and that's why we include it in our code. If you say false, you don't have to include it. Simple as that. Now encrypted data. This is actually used in both the AS-REQ and AS-REQ. But in this specific code, it's going to be referred to as KDC rep and KDC rep and rec. KDC rep and KDC rec. Essentially because within the encrypted data type, there are these 3 fields within it, which is why, as you saw here, if we can go to it, encrypted part E type, it has that E type, and then it also has the cipher as well. And that's because the encrypted part of the AS-REQ is actually using this encrypted data sequence as well. And then here we have a class for ticket, which just sets a tag for a ticket. So essentially this ticket has the value of 1. It's constructed because it is a sequence, and then has a class of application. And then it goes through here and then actually lists the parts that are within it, which are ticket vino, which is closely related to pvino. So instead we have to change the name from its default and then give it the tag value. And then the realm, we saw what realm was, S name, principal name, encrypted part, encrypted data. So yeah. And then for host address, you'll see this probably a little lower, but it gives you the address type and then the addresses in here. Those are the 2 fields that make up this sequence. and then host addresses. Essentially, it gets a host address and then puts it in that component type. Then you have the Kerberos flag, and then the KDC option is also equal to the Kerberos flag, but the Kerberos flag actually uses this bit string, which is used by UNIV, which is a class that we imported so that we can do this project with a little bit more ease. And here you can kind of see what I was speaking of earlier. Oh, I'm tripping. So actually, encrypted data is used in the REQ, KDC REQ body. However, it's used in optional components, encrypted authorization data, which we didn't use. So the main focus for our encrypted data is actually in that AS-REQ, which is right here. And that's why we're able to grab that E-type and then the cipher. And then we viewed this already, reviewed this here. Yeah, reviewed this already. And then this is how we're setting some of the components for the principal names. So we use this function here, which essentially just like setting the name by getting the name from here. So that's all this is doing. And then the same thing with sequence set iter, except it's expecting multiple values. Now this one we ended up not using because I went through and physically created all the tags. What would have happened would have been if I used this for each tag, essentially something along the lines of essentially just get that number from it and then set that, and that would probably been it. But this was built out when I was first trying to build the AS-REQ message, so that's why you see this here. And then finally we have the principal object, which I kind of described to you guys earlier. And then these are just some things within it, but essentially it's just correlating the name for is it C name and S name, so that they actually fit those values. And then we already went over connection, and then finally type. Now this is simply something I built out for the Kerberos time that we used here and here. So essentially it just goes through, pulls the actual not Kerberos time, pull the actual time from here, and then it makes these transformations to it so that it's returned in a way that the KDC likes it. Now with that, that's essentially all for this project. So I hope you guys enjoyed. I hope you learned something new. I hope you were able to dig into this, and hopefully looking at this didn't just make your mind explode, because trying to do this the first time for me, it took quite a while for me to understand what I was doing, and then for me to actually make it all come together. But in learning something like this, I do want to help you guys to see that even tools like this that you've been using are things that you can also build up to, and essentially you can do these things too. It's not impossible. But actually, before I end, I know one short thing before I end. I'm gonna show an example so that we can see that this works properly. So what I'm gonna do, I'm gonna go into our domain controller, log us in, and then we're gonna open this up because I have been transferring this to and fro working on this project. I'm gonna open this up here so that you can see that once we run it, we would be able to get the username, in this case for Alice, because she's the only one with pre-authentication disabled. Now for this, like I said, I've already kind of ran some tests on it. So what I'm gonna do is I'm gonna go back to my old commands, because this will help you to see how these work. So going through this is with the host name as opposed to the IP address. But with that, we get this hash for Alice. If it scrolls up, here we go. As you can see, it has that AS-REQ 23, which does mean that it comes back in that RC4 HMAC format. and that's how it's encoded. If you were to put this into hashcat and use the ROQ.txt file, you should be able to get that password. Now, and I used the output file, which I didn't even realize. Yeah, so it's going to go into this Alice hash.txt file. And here we can see that we have the hash as well. Now I'm gonna try it with a file, and that should be it. Yeah, users.txt. I hope this didn't write out to anything. No, it went to the output.txt. So we're gonna come grab this. Oh, is Alice the only one in here? But essentially you can see that it works in both ways. Grabbing just a user from a specific file, or grabbing user from a specific file. For the output.txt, I realize now that I have it only put the username in there if you do grab a hash. However, it does show you down here in the terminal that there was error processing David because he does have pre-authentication enabled, or there was an error. And in this case, we know that both Bob and David have pre-authentication enabled. So now we can actually get to closing. I'm sorry, I forgot that I had to show you guys that it does work. So with this tool, I'm hoping that you guys were able to get some hands-on experience, understanding how to build some things out, and knowing that you yourself, yes, you have the ability to build amazing tools with all of the information out there. This should be something that's relatively simple. However, going through the trials and errors really helps build up your skills, as well as builds up your confidence as someone coming into the cyberspace. And as for me, I know I'm the novice, probably gonna stay the novice forever, but I don't want my knowledge to be capped off at a certain value, so I'm gonna continue to learn and dig deeper into things that I'm interested in. And that's what I'm hoping that you guys take away from this as well. But let me stop talking your ear off. Whew, that's it for me today. If you guys like the video, go ahead and hit that like button. If you guys enjoy what I'm doing here, go ahead and hit that subscribe button as well. If you don't like what I'm doing, or you have an issue with how I relay my information, please let me know, as I'm trying to improve myself too, so that I can get better for my community at large. With that, I am done. Novice out. Peace.